very good afternoon to all of you. This FDP is being organized by the Internal Quality Assurance Cell of St. Paul's College in association with Mount Carmel College IQAC under the Paramar scheme. We extend a warm welcome to you. I now hand over the stage to Ms. Pallavi to render the welcome address as well as introduce our resource person of the day. Over to you, Ms. Pallavi.
Thank you, ma'am. I hope I'm audible. Yep.
Yes.
Yes, you are.
Yeah. Okay. Very good afternoon to everybody present here. It's my honor to welcome the resource person for the day, Dr. Satish P. Dr. Satish P has 6 years of teaching experience and 4 years of research experience. He's done his doctoral degree from VIT Vellore. He's specialized in finance and accounting and has been doing the research in the same area as well. He's completed his MBA from Annamalai University and BCom from SRM University, Chennai. Currently, Satish sir is working as assistant professor in Christ, Bangalore. As a part of his research work, he had published articles in peer-reviewed journals, which include Scopus Index journals and ABDC listed journals as well. He's presented research papers in national, international conferences, and also attended a lot of faculty development programs and workshops which are related to SPSS, AMOS, and econometrics. He went as a resource person for various FDPs, guest lectures, and he's also chaired the sessions in many conferences and workshops to various reputed colleges. He's well versed in handling SPSS, RCraft, EVOs for financial data analysis in research area. He is a gold medalist and earned first rank in BCom at SRM University, Chennai. He's also earned class topper in MBA and 39th rank holder in Anna University. He received Research Award 2017 for the publication in VIT University, Vellore. Recently, received the award of Best Researcher 2020 conducted by Pondicherry Research Society in Pondicherry. We welcome you, sir.
Thank you, ma'am. Thank you, hello, my introduction. Am I audible? I hope I'm audible now. Yeah. Once again, I thanks to St. Paul's College and Mount Carmel College for giving this opportunity. Let us begin the session. And today, agenda, the day 5 today. So 4 days we have completed successfully. This is the 5th day. We are going to look into the content of correlation and regression analysis. Okay. So before going into the correlation and regression analysis, we have discussed bivariate analysis. We have started bivariate analysis yesterday with the chi-square. Okay. So chi-square, comes under bivariate analysis. For doing chi-square, we should have two variables. Okay, we should have a two variable. The two variables also should be categorical variable. Okay, you cannot use the metric variable like interval or ratio scales. You cannot use it for chi-square. So before choosing the analysis, first you have to identify what kind of scale we should have. Okay, it depends upon the questionnaire. Okay, so first you have to look at the objective. Based on the objective, what analysis is apt for our study, that we have to determine, we have to decide. Okay, so all those things, everything is based on the questionnaire what you have prepared for the study. Okay, so once if you prepare the objective should be related to the, okay, based on the questionnaire and based on the objective, we have to choose the analysis for our study. Okay, so we have discussed, I think Aarti ma'am also was discussing about the T groups, as well as I have discussed about the chi-square test with the continue of yesterday. And today we are going to talk about the correlation and regression analysis. As I told you in the yesterday class, the purpose of each and every test is very important. Okay, as a researcher, those who are doing in the social science area, you must know which analysis is we have to do, on what basis we have to do the analysis. Okay, so objective. So why we have to do the correlation? Why I should do the regression analysis? What is the purpose of chi-square? Once if you clear with this objective of each and every test, then you can able to define in your paper properly, and you can able to define during your viva. Okay, so let us move on to the correlation analysis. Yes, so correlation analysis, that is belongs to bivariate analysis. It is one of the bivariate analysis. Normally, the correlation analysis denoted by small r. Okay, so the representation of small r is correlation. Okay, what is correlation, gentlemen? Suppose if you want to find out the relationship, suppose if you want to explore the relationship between the variables. Okay, when I say relationship, when you write a relationship in your objective of the study or in hypothesis, you must do correlation analysis. You cannot use chi-square test. You cannot use regression analysis. Understand? So whenever I see relationship, you have to keep it in your mind. Correlation. We have to do correlation analysis. Okay. So it may be a two variable or more than two variable. Okay. So to find out the degree of relationship between the two or more variable, then we have to do correlation analysis. That is the purpose. That is the purpose of doing correlation analysis. Okay. Now, relationship. What kind of relationship? There should be some logic. It may be a positive relationship or negative relationship or no kind of relationship between the variables. So all those things we have. Let us discuss in the forthcoming slides the theory. So the basic concept is very important before going into the hands-on session. Okay, so to explore the relationship between the two or more variables, we have to do correlation analysis, that is represented by small r. Okay, now what is the condition? Which kind of scale I should have? Okay, which kind of scale I should have to do the correlation analysis? The scale should be, I told you two variables. The two variables should be either interval or ratio scale. Either interval, I have mentioned only the interval, either interval or ratio scale. Okay, I told you both the scale, both the interval and the ratio scale belongs to metric data, where we can able to find out the average by using those variables. So the condition for the correlation analysis is you should have either interval scale or ratio scale. You cannot use correlation analysis for nominal and ordinal scale. I hope you are clear. So that is the condition for the correlation analysis. So it is otherwise known as correlation coefficient. Correlation coefficient. Now, when we coming to the types of correlation, there are two types of correlation. One is simple correlation and another one is multiple correlation. What is a simple correlation? The simple correlation means when you have only two variables. I'm talking about only the variable. I'm not talking about dependent or independent, nothing. In the correlation analysis, no dependent, no independent variable. Okay, just we are going to explore the relationship between the variables or among the variables. Suppose if we have a two variable, then it is called simple correlation. Suppose if you're using correlation analysis by using two variables, then it is called simple correlation. So what is multiple correlation? If you are going to use more than two variables, if you're going to use more than two variables, then it is belongs to multiple correlation analysis. Okay, these two things we are going to see in the hands-on session. Coming to the next one, what are the methods of correlations we have to do the analysis? Okay, we have four methods of doing the correlation analysis. We have a scatter diagram method. We have Collinearity's coefficient of correlation. That is the most popular method of doing correlation, which is everybody using, all the researchers. Okay, and then Spearman rank correlation coefficient, and finally method of least square method. All those things, all the methods of correlations we have already come across theoretically, but when we coming into the SPSS or any kind of software, how to go about it, all those things. So scatter diagram, what is the scatter diagram? So scatter diagram, we can identify, we can explore the relationship between the variable graphically by graphical representation. So this is the scatter diagram. Okay, so first one, if you look at x-axis and the y-axis, and this is called linear, the straight line called linear relationship. Linear relationship. So look at the dots. All the dots are represented the variable. The variables are represented through dots. Okay, so the variables are closer to the straight line. Okay, so then it is called positive correlation. Okay, so are these two variables moving together in the positive direction? So look at this. Positive from 0 to it is moving towards the up direction. So which means that positive correlation that is represented by R equal plus 1. R equal plus 1. Coming to the next one. Okay, let me again in the next slide, I'll tell you in detail about with example about positive, negative, and no correlation. Coming to the next one, next scatter diagram, negative correlation. When the direction is going toward downside, when the direction is going toward downside, then it is called negative correlation. Okay, so the negative correlation R equal to -1. Coming to the next one, there is no linear relationship. Look at, there is no straight line here. The variables are scattered, the data are scattered in the diagram, then it is called no correlations, which is the representation of R equal 0. Okay, so this is the scatter diagram. Normally, why we are not applying this scatter diagram, because you cannot find out the relation in terms of percentage. Only you can see the direction, whether it is a positive or negative, that can only identified through the scatter diagram, but we cannot find out any percentage. Okay, the percentage of relationship. Coming to the next one, as I told you in the scatter diagram, positive, negative, or no correlation. Positive correlation means you have a two variable. When the two variables are moving together in the same direction, that is called positive correlation. Say, for instance, publicity expenses, advertisement. So when the company is spending more amount on advertisement, the sales will be increased. The sales will be increased. So when the company spend more amount on advertisement, the sales also will be increased. So both the variables are moving in the positive direction. Then that is why we are calling it as positive correlation. Coming to the negative correlation. What is negative correlation here? When one variable increases, the another variable comes down. Another variable will come down. Okay, so what is the example here? When the price of the commodity increases, when the price of the commodity increases, the demand for the same commodity will come down. Okay, so that is one variable increases, the another variable decreases. That is negative correlation. Coming to the next one. So this is what I have discussed in the earlier slide. The example I have given. Yeah. The next one is, what is the range of correlation? In theoretically, what we have come across to, the value of coefficient of correlation, it is denoted by R. The range for coefficient of correlation is -1 to +1. Suppose if I am getting more than +1, then your correlation answer will be wrong. Okay, so -1 to +1, your range will be lies between -1 to +1. So how to identify in the values whether it is a positive or negative or no correlation? If R equal to +1, if R equal to +1 exactly, then it is called perfect and positive correlation. In case if R equal to -1, that is called perfect negative correlation. Perfect and negative correlation. And the third option, what we have is if R equal to 0, then we can conclude that there is no correlations between the variable. Okay, so this is the interpretation based on the value which we are going to get from the output. And coming to the next one, yeah, we are moving on to the hands-on session. First one, I think I hope everybody received the data set which is shared by Dr. Babu sir. In that one data set that contains income and expenditure of the family. Income, and that is a small data set. Just for basic, we will see that one. And on the next one, we will see what Artina discussed, that questionnaire we will take for the correlation analysis. Now, look at this. Income and expenditure. We have a two variable in the data set, income and expenditure. Now we are going to find out the relationship between the income and expenditure. Okay, so what is the percentage of relationship showing the income and expenditure? Okay, so now this is the objective, to explore the relationship between the income and expenditure. Based on the objective, what we have to do, we have to now look at your null hypothesis. There is no relationship between income and expenditure of the family. Income and expenditure of the family. What is that? So there is a null hypothesis. The word relationship you should mention in the hypothesis. You cannot mention association in the correlation hypothesis. So whatever analysis we are doing, based on that only we have to write the hypothesis. Hypothesis will not be constant, will not be same for all the statistical tests. Coming to the alternative hypothesis, there is a relationship between income and expenditure of the family. Okay, now with this, we are going to test whether we are going to either accept the null hypothesis or reject the null hypothesis. That is what we are going to see. Now, how to go about it? Go about the correlation in the SPSS. Go to SPSS. In the data view, you have to select the option called analyze. Then correlate, you have to select. Then you have to select on bivariate analysis. Why bivariate? It is two variable. We are using two variable for the analysis. Okay. Now, I request everybody open the data set in your system. Just give you a minute. Yeah, just a minute. I'm opening the SPSS. I hope everybody opened the SPSS software. You can import the data, that income and expenditure data set. You can import from the Excel sheet to the SPSS. Yeah, and just I'm going to import the data file from the folder. Go to File, Open, Data. That I have saved in F. Right. Yeah, just select simple correlation, first one. Yeah. Now, this is a simple data, just I have entered. We will use that more than two variables also, just for your understanding how these two variables, using these two variables, how to explore the correlation analysis in SPSS. Now we have a 7 respondents data, income as well as the expenditure. Now what we have to do, we are going to find out the relationship between income and expenditure. Go to analyze, go to analyze. In that, we have to check correlate. Okay, so we have to select correlate. In that, you have to select bivariate. Once again, repeat that. Go to analyze, correlate, and bivariate. Then you have to post two variable in the right hand side variable box. Okay, income and expenditure. Next one, options. In the options, no need to change anything. By default, let it be. Then everything will be same. Okay, no need to change anything. Here, Pearson coefficient of correlation. Pearson, that is called Pearson's coefficient of correlation. What we have discussed theoretically, manually, called Pearson coefficient of correlation. So that is, they have given here Pearson. Okay, now okay. First, you have to click OK. Now we'll be getting the output. Now we have received the output of correlation. Let me share. Yeah, this is the output of simple correlation. This is output of simple correlation. Now this is the correlation table. The another important thing is we have to interpret how to interpret the correlation analysis. Okay, so let me tell you what are the things you have to be considered. We have two variables. First, look at the row wise and the column wise. We have a two variable, income and expenditure. Compare and income. So when you compare income and income, obviously you'll be getting 100% relationship. Okay, that is why it has given 1. Now we have to compare the expenditure. We have not compare. We have to see the relationship with the expenditure. What is the relationship? Income and expenditure. It is showing 0.83, 83%, which means that the income and expenditure showing the relationship by 83% or 0.83%. Okay, now this is relationship in terms of percentage. Now, whether it is statistically significant or not, it is statistically significant or not, how to check? We have to check the probability value. So what is the probability value here? The second column, significance. Significance, we have 0.021. Okay, now I need an answer in the chat box. Can you tell whether we have to accept the null hypothesis or reject the null hypothesis? Yes, quick. I need a quick response from you all. We have to accept or reject the hypothesis. Yes.
Null hypothesis. Sir, reject the null hypothesis.
Reject the null hypothesis. Fine. So because since it is lesser than 0.05, we have to reject the null hypothesis. Now, what is the alternative hypothesis? There is a significant and positive relationship. Why positive? Because it is showing plus value. There is no negative value we are finding. Okay, it is showing the positive value. That is why we have to conclude that, we have to interpret that there is a positive and the significant relationship between income and expenditure by 0.83%. Okay, so this is the way you have to interpret for the correlation analysis. Suppose if you have more than two variables, the same interpretation you have to do, but you have to interpret separately, not along with all. You can interpret all the variables in one sentence. If you want, you can interpret separately. Okay, by seeing the relationship between two variables like that. Okay, I hope you have cleared. And then you can see the aesthetics in the 0.83, which means that below the table it's showing one aesthetics represents that correlation is significant at 0.05 level. Yeah, obviously it is lesser than 0.05. That is why it is statistically significant by 83%. Let me share the PPT. This is visible, the PPT. Yeah, fine. Yeah, now, so whatever I have discussed, that is simple correlation. That is two variables. If you are using two variables, that is simple correlation. I have given one more data set also for simple correlation. When you free, just you work on the simple correlations based on what I have done in this session. Now coming to the next one, multiple correlation. Same concept, interpretation, everything is same. But here number of variable is more than 2. Okay. Now, based on the Artiman questionnaire, it's yesterday what we have discussed, to find the relationship between interpersonal relationship, motivation and commitment, group, team cohesiveness, and upgrading knowledge and balance. So these are all the things we have seen last 2 days in the questionnaire. Okay, so these are all the construct which measures the team effectiveness in the organization. Okay, so here we have seen interpersonal relationship. To measure the interpersonal relationship, we have 5 or 6 items. Okay, now I'm going to see the relationship between the dimensions, or we can say construct. Okay, now for this we have how many variables? 1, 2, 3, 4 variables. Okay, so this is 4 variables. Everything measured in scale. You have to look at that also, the scale. What kind of scale? This is in the questionnaire they have mentioned like a 5-point Likert scale, interval scale. Okay, now this thing we can apply for correlation, multiple correlation, because it is more than 2 variable. That is why we are choosing multiple correlation. Now coming to the hypothesis also same. We have to mention the word relationship. There is no relationship between IR. IR means interpersonal, MC means motivation and commitment, knowledge and talent. Okay. Alternative hypothesis, there is a relationship between these variables. Now, coming to the SPSS. Yeah. Now you can able to see the data set which is shared by, which is given by Aarti ma'am. we have, I think we have computed the variables. Okay, all the items we have computed for each and every variable here, IPR, NC, TC, and KT. Okay, now go to analyze. These are all the computed values. Go to analyze. The same option. Go to analyze, correlate, then bivariate. In that, we have to take only the compute variable, not items. We are not seeing any items. All the 5 or 6 items consist of one variable here. Okay. Now, interpersonal, motivation, team cohesiveness, and upgrade. These 4 variables I'm going to test whether is there any relationship or not. Now, options, no need to change anything. Now we will be getting the output. Yeah, we got the output. Now, this is the output of multiple correlation. This is the output of multiple correlation. What is that? Interpersonal relationship and interpersonal relationship. Here, what is that? 1. Now, interpersonal relationship, compare with the, not compare, it is seeing the relationship with the motivation and the commitment. So what is the percentage? It is showing 63%. 63% relationship between the interpersonal relationship and motivation commitment. Yes, Nikki, you have a doubt, you can raise.
Sir, please share the screen, sir.
Yes, sir. Screen is not visible.
Yeah, I think you can able to see the.
No, screen is visible, Roman.
Visible.
Screen is visible, sir.
Yeah.
There is no issue.
Fine. Now, this is the output of multiple correlation. We have to see the first row. First, if you look at the first row, then we can interpret everything. Okay, no need to look at second row, third row, fourth row. But for the writing an article, we have to copy and paste it in the Word document. Some of the values we have to omit. Okay, let me show you how I have written the correlation analysis with the interpretation for my article. So here, interpersonal relationship, we have to look at the relationship with the motivation and commitment. It is showing positive plus 63%, positive 63% relationship between motivation and interpersonal. Okay, so what is the significance level? It is less than 0.01. Okay, so what is the interpretation here? There is a positive and a significant relationship between interpersonal relationship and motivation by 63% at 1% significance level. Why 1% significance level? Because the significance level, everything showing 0, 0, 0. What is the 0.00? Which means that less than 1%, less than 0.01%. Okay, coming to the next one, a team cohesiveness, 42% relationship. This is also significant. Coming to the upgrading knowledge with the inner relationship, 48% relationship at 1% significant level. Now, what is the number of respondents in your data, respondents in your study? Okay, this is a simple thing, the correlation analysis, where you have to do for your study whenever you're so you can use the same for your study. That should be based on the objective. Okay, let me share. Let me do one more demonstration also. Yeah, and one more data set, and go to file, open data. Yeah, one more data set we have multiple correlation, that is finance data, time series data. Yeah, this is the time series data because the data which we have collected throughout the year. Okay, now we have 4 variable. What is that? GDP, government expenditure, consumption, investment. Okay, now we have, I think we have come across to the calculation of GDP. The GDP is calculating or will be estimating based on the government expenditure, consumption, investment, all those things. Okay, now import and export also. Now I didn't include the import and export. So by using these four variable, I'm going to check what is the relationship between those variables. Go to the analyze, correlate, bivariate. Okay, select these four variable, put it in the variable box, then click OK. Now we got the output of multiple correlation. Okay, so you know how to interpret the multiple correlation. Okay, I hope everybody clear. Now let me show the article how I have written the interpretation for correlation analysis. Sure. Yeah, you can see the article. Actually, this article, when I was doing PhD in VIT, I have published this article in IUP Journal of Applied Science. Okay, when I was publishing that time, there was this journal was indexed in ABDC C category. And now this journal now indexed in ABDC C category listed. So this is the title, Dynamic Relationship Between Institutional Investors and Indian Stock Market and Empirical Analysis. Now, for this study, I have applied correlation analysis based on the objective. Let me show the objective also. Yeah, here in that objective, somewhere, yeah, understand the nature of relationship. Yeah, in the objective itself, see in the objective, I have written indirectly. Okay, so I didn't mention relationship or influence, nothing. I have written indirectly the purpose behind this study, understand the nature of relationship, and then effect. When I say effect, you have to definitely go for regression analysis. Okay, now one of the objectives here, a relation that might exist. So when I see the relation, you have to definitely do the correlation analysis. Based on that, see, look at the hypothesis. Hypothesis, I have mentioned relationship, relationship, relationship. Okay, because I have applied correlation analysis. Okay, now look at here the correlation table. So what is that? This is the way you have to present in your work. Okay, so you cannot paste all the values, whatever we are getting output in the SPSS. While preparing the Word document, you have to put only the important values. Okay. Now, this is why I have given the empty values here, because no need, the same values only will be repeating here also. Okay, so that is why I have given the blank. So for clear understanding, okay, for clear understanding of the audience, for clear understanding for the reviewers, okay, so even the editors also. So that is why I have given, this is the writing style of the each and every researcher. Okay, so the writing styles will be coming from when you do more and more literature. Okay, so this is the correlation analysis table, and this is the interpretation for this paper. So this is for your understanding. Let me show one more paper also. Yeah, I have received one doubt. What is that? Sometimes the magnitude of correlation is lower and significance high, which means that it is showing the relationship, but it is not statistically significant. It is not statistically significant because it is showing, no, what is that? 0.23. Okay, so it means it is a correlation is very less, not highly significant correlation. So you can interpret, no need to mention lesser, higher, weak correlation. Just write there is a significant and positive relationship between two variables by 23%. Okay, no need to mention weaker or higher correlation at all. But the correlation value lies between -1 to +1. I hope you have cleared, Archana. Okay, fine. Let us, with the insight of this correlation analysis, let us move on to the regression analysis. Yeah, I think I have given the link for a link also for referring the correlation analysis along with the interpretation. Let me share these links. Now, coming to the next one, regression analysis. So what is that? What is the relationship between correlation and regression? Correlation is something to find out the relationship between the variable. So why we have to do regression analysis? Just in correlation, just we have seen only the relationship, whether it is a positive or negative. Simple correlation we did, multiple correlations we did. Okay, now why we have to do the regression analysis? Regression analysis we have to do to find out the cause and effect between the variable. Cause and effect. In simple way, I can say to what extent influence one variable on another variable. Influence one variable on another variable. So when I say one variable on another variable, here we must classify the variable which is independent variable. Okay, so in correlation, no need to classify dependent and independent variable. But in the regression, we have to classify dependent and independent variable. Okay, so the purpose of doing a regression analysis is to find out the cause and effect between the variable. So which variable is highly influencing on the another variable. So when I say the another variable, that is called dependent variable. Let us see with the example. Predicting the value of one variable. So this is another meaning of regression analysis. Predicting the value of one variable given the value of another variable, when those variables are related to each other, that is called regression analysis. Okay. Prediction. So what is the prediction? Prediction, estimation, or forecasting. For all those things, we can apply this regression analysis. Okay. Fine. Regression is the basic analysis for the prediction. We have now structure equation. To do this structure equation modeling, you should know at least something about the regression analysis. Advanced model of regression analysis is called a structure equation. Now all the researchers are, all the PhD scholars are doing same model. Okay, so that is the advanced model of this regression analysis. Now, what is the condition? What is the condition of doing the regression analysis? The variable, the assumption, the variable should be metric data. Here and there I have changed the variable name. There I have mentioned interval or ratio. Okay, so when I say interval and ratio, that both the things comes under metric data. But I have given metric data. Metric data means where we can find out the average by using those variables. So the variable should be metric data, either interval or ratio scale. Fine. Now, as I told you in the beginning of the regression analysis introduction, we have to first classify dependent and independent variable. So when you have one dependent, one independent variable, then it is called simple regression. When you have more than independent variable and one dependent variable, then it is called multiple regression. So what is dependent and what is independent? Dependent means depending something on other variable. Independent means whatever changes happens, that variable alone will not change anything. Let us see the example. Here I have given one statement. What is that? Influence of advertisement on sales. Now tell me, just put it in the post chat box, which one is dependent variable, which one is the independent variable. In that statement, how will you classify the dependent and independent variable? Just post it in the chat box, please. Participants, please be active. Just no need to unmute and tell. Just post your answer in the chat box so that I can discuss. Yeah, sales is the very good. Thank you, Rukini madam. Sales is the dependent variable, and advertisement is independent variable. One independent and one dependent variable. So the sales is depends on advertisement. We cannot say 100% is sales is completely dependent on advertisement 100%. There are some other factors also which will influence on these sales. Maybe the quality of the product. Okay, the post sales satisfaction. Okay, so there are several factors is there. Now we have only one variable, dependent and dependent variable. Coming to the next statement, what is that? Income on expenditure. Expenditure is depends on the how much income you earn in a month. So whenever the income is increases, your consumption pattern also will be increasing. Okay, so that is the thing. First, you have to classify which one is the dependent and which one is the independent variable. Okay, with this, yeah. If you look at this slide, yeah, very good. I am getting a good answer from all the respondents. Fine. Now, the status for regression analysis, the dependent variable should be metric one variables. Please keep it in your mind. For regression analysis, the dependent variable should be metric. Even for the independent variable also, the variable scale, the scale should be metric. Okay. Now, for doing this simple and multiple regression, your dependent variable should be one, not two dependent variable, three dependent variable. Suppose when you want to apply two or three dependent variables, then you have to go for structure equation modeling. Coming to the independent variable, you can include any number of independent variable for this regression analysis. But the condition is all the variables should be metric data. No nominal, no ordinal. Okay, so both the variables should be metric, one dependent, multiple independent, that is called multiple regression analysis. Coming to the next one, if you look at this graph, why I have mentioned this graph, the purpose of this graph is simply we are talking about linear relationship, linear regression analysis. So what is a linear? Linear means it is a straight line. It's a straight line. Okay, so in the line, how the variables are closest to the straight line. Based on that, we can able to interpret. Okay, what is this non-linear function? Non-linear means it is not in the straight line order. So when you have a linear, then you have to do linear regression. So what about non-linear? For non-linear, we have different kind of analysis. Suppose if your data is non-linear, you cannot apply regression. So the data should be linear. All those things, it is a theoretical aspects. Yeah, coming to the next important thing is simple regression and multiple linear regression. As I told you, simple regression nothing. It's I have received one question from Dr. Tiram. How to identify the linear relationship? Actually, when I say the relationship, so here we have discussed the output of correlation analysis, positive, negative things. Positive means it is a positive relationship. That is called linear relationship. We have to interpret that as linear relationship because, which means that what is the meaning there? All the two variables are closer to the straight line. That is why it is showing the relationship. If you are not getting the relationship, then we can say non-linear. Okay, so this is the way we have to understand practically here. Okay, now I hope you understand. Okay, fine. Okay. Simple linear regression, one dependent variable and one independent variable. So the dependent variable, actually, the dependent variable is always represented y. Okay, always represented y. Independent variable is always represented in x. I think you please make a note of it. Regression, there is one constant regression equation is there. The regression equation basic is y equal to a plus bx. What is y equal to a plus bx? This is the base regression, the basic model for the regression analysis. Yeah, exactly. Nidhi, I think one more question I have received. Nidhi, should we first check correlation, then we can go to the, yeah, obviously we have to check correlation analysis, then we have to go for the regression, because in the correlation we have explored only the relationship among the those variables, which variable influencing the one variable on the another variable. So for that we have to identify dependent and independent variable in this regression. Okay, that is the purpose of doing the regression analysis. So y equal to a plus bx. So this equation is, you have to keep it in your mind always. Okay, so what is y? Dependent variable. What is x? Independent variable. So let me show the another slide. So now simple regression here is single predictor, because we are using only one independent variable, that is x. How these x variable influencing the y variable, dependent variable. So you can see the arrow mark here from x to y. Coming to the multiple regression, one dependent variable. So always, whatever it is, a simple regression or multiple regression, the dependent variable should be one. Okay, so that should be metric data, not categorical. If it is a categorical, then we have to do logistic regression. Okay, multiple linear regressions, we have one dependent variable and multiple independent variable. Now in the research world, they are not calling it as a dependent and dependent variable. There are several names for dependent and dependent variable. What is that? Dependent variable, sometimes no, we can see the endogenous variable, the other name for dependent variable. Independent variable, exogenous variable, or otherwise known as explanatory variable. Okay, so there are several names is there. Just you refer books. I think Gujarati books, it is there. The other name for dependent as well as the independent variable. With this, we'll move on to the next one, the equation. What I told you in the earlier slide, y equal to a plus bx. This is for your understanding. Actually, if you remember this y equal to a plus bx, that's enough. Okay. Now, this is y means the dependent variable. B means here you can hear the beta 0, or you can mention a. What is that? Constant. This is constant. Whatever changes happening in this explanatory variable or independent variable, this will remain constant. Intercept. Okay. Plus, this is the coefficient. The beta 1 is coefficient of independent variable. B1 means coefficient of independent variable. Independent variable is what we are going to consider as an independent variable. Plus, what is this? Random error. This is very important. We are looking only simple linear regression. One dependent, one independent. We cannot say advertisement unknown influencing the sales. There are other factors also which is influencing on the sales, but we don't know. We are considering only the advertisement. What about other factors? We don't know the other factors. That other factors is called, that which is not considered for our study, that is called unexplained variable. Those variable which is not considered for our study, then it is called unexplained variable. That is called random error. So what is that? This beta coefficient of independent variable is one independent variable, that is called explained variable, and this is called unexplained variable. Okay, so this is a simple linear regression equation, simple equation. Coming to the next one, multiple regression. Just nothing. If you remember the simple regression model, then automatically can understand the multiple regression. Just we have to extend the independent variable in the equation. What is that? Y equal a plus b1 x1, which means the first independent variable, plus b2 x2. b2 x2 means coefficient, beta coefficient of independent variable, plus dot dot how many independent variable you are considering for the study. Okay, so that's why in the formula it has mentioned b and x. How many you can include more than 10 variables also as the independent variable, not a dependent variable. Plus error. Okay, so this is the equations. Then we will see with the data set all the equation. I hope you have figured both simple and regression model. Yeah. Any doubt up to this before going into the hands-on session? If you are just, I'll give 5 minutes. If you have any doubt, you can clarify. You just post it in the chat box. I'm ready to answer for that. Suppose if I keep on continue, then you will forget what kind of questions you will ask at the end of the session. So better if you, I just am giving a time to take 2 or 3 minutes also instead of 5 minutes. Just post your questions in the chat box so that I can continue further. Otherwise, if you don't have your questions to ask, I can go further. Yeah, different types of regression. Good. This is the basic regression. We have a logistic regression. Under the logistic regression, we have binomial logistics, multinomial logistics. Okay, I think more than 7 types of regression we have. Okay, even this decision tree regression we have. I can say numbers, but I cannot list out the number of the type of regression. Okay, this is the basic regression. Yes. Yeah, residuals. Good questions. Residual means what I have explained here. Error. Error. What is the error? Unexplained variable. So when I say unexplained variable, that is called error. Okay. So there is a manual calculation also we have error, which means that actual minus estimated. Actual minus estimated is called error. Okay. So the error and all will be mostly considered in the time series data. Those who are doing a research in finance, the error will be most important. That time you have to consider, you have to concentrate more on the error. Let us see in the here also the regression model, how we have to consider the error. Yeah, fine. Yeah, if you use correlation, then it is apt for to do the regression analysis. You can show the relationship at the same time to what extent one variable influencing on the another variable. Fine. Fine. With this, yeah. With this, let us move on to the hands-on session. Yeah, I'll come to the next. I think after finishing the session, I'll come to answer for your question. We move on to the hands-on session for the regression. Simple linear regression. So when you have one dependent and one independent variable, you have to do simple linear regression. So the objective of the simple linear regression is to find the influence of income on consumption. You can use the word influence or impact. So when you use the influence, you must go for regression analysis. Okay, so income and consumption. So here we are going to keep consumption as a dependent variable. Independent variable is income. Okay, there should be some logic. You cannot mention something like a dependent and independent variable. There should be a basic knowledge to be considered as a dependent as well as the independent variable. Okay, so now this is the objective. Now I have clarified what is the dependent, what is the independent variable. With that, I have to frame the hypothesis for my study. What is that? There is no influence of income on consumption. That is the null hypothesis. What is the alternative? There is an influence of income on consumption. See, look at the hypothesis. See, yesterday I have taught chi-square. Today correlation analysis we did. Now regression. Look at the hypothesis. Null hypothesis alternative same, but the word is keep on changing based on the statistical test. Now there is an influence of income on consumption. Okay, now finally we have to accept or reject based on the probability. So to do a simple regression, what is that? How to go about the SPSS? SPSS in that data we analyze regression and linear. Okay, so please open the data set of consumption and income. Yeah, just go to the file. Open data. You can open simple regression first one. Simple regression. Just click OK. Sorry, not this one. Just open second one, not first one. So second one. Second simple regression. Yeah, this is the 20 respondents consumption as well as the income. Go to analyze. Go to analyze. In that you have to select regression. You have to click on the regression option and then second option linear. Linear regression. Why it is? It is a straight line. Linear regression. I have received one questions. What is that? Fine. Go to analyze regression linear. Okay. So when you click linear, it will come like this. What is that? Dependent and independent box in the right hand side. So here we have a two variable consumption and income. Is it visible now? SPSS. Can anyone check? Is it visible the screen? Yes. Okay. Fine. Now in the right hand side, we have to post which one is dependent and which one is independent variable. That is why we have to classify before itself. Okay. Now the dependent variable is consumption. Just post it in the consumption box. Sorry, dependent variable box. Then the income variable, we have to post it in the independent box. Okay. Now, after posting the dependent and independent variable, we have to select a few options here. Statistics. Here, what is that statistics here? Estimates, model fit. Okay, so just as it is, no need to select anything, but only one thing is you have to select, that is collinearity diagnostics. That is called multicollinearity. But we are doing a simple regression, but no need to check collinearity. So when you do more, when you select, when you are using more and more independent variable for your study, that time only you have to select this collinearity diagnostics. Okay, then we will check. We'll move on to the multiple regression. Plots also no need to consider anything. Just let it be as it is. Here also no need to consider the linear regression. No need to consider anything. Just let it be. Options, no need. So no need to change anything in the simple regression. Just only thing is you have to post dependent as well as the independent variable. Just click OK. So now we have received the output of the simple regression in 3 tables. What is that? One is the first model summary. and second table is ANOVA, and third table is coefficient. So now how to interpret these three tables? That is the important task. Now look at this. The first model summary. This is model one. Why we have only one model, y equal to a plus bx. Coming to the R. R means what is the relationship? You can interpret the correlation. I think someone asked in the chat box. First we have to do correlation, then we should go for regression. Better you can see the regression, you can see the correlation here itself, but we don't know whether it is a significant or insignificant. So for that one, we have to do correlation analysis. So R represents correlation analysis. It is showing 96% relationship. R square. What is that R square? This is very, very important. The overall model. What is our model? Income and expenditure. Sorry, income and consumption. So the consumption, the model, the overall model explained by 93%. So the income alone predicting 93% on consumption. What about remaining 7%? The 7% is called unexplained variable. We cannot exactly predict which variable influencing on the consumption because we have considered only income. The income alone predicting 93%. So that is the clear explanation of R square. The R square means coefficient of determination. Coefficient of determination or degree of determination. So what is the interpretation for the R square? The overall model explained about 93%. Or we can say in other words, 93% changes in the dependent variable. What is the dependent variable? Consumption. 93% changes in the consumption, which is explained by the changes in the income. So that is the interpretation for R square. What is adjusted R square? It is not that much difference between R square and adjusted. See, for simple regression, no need to consider adjusted R square. Okay, R square itself is enough. What is adjusted R square? When you include more independent variable, you have to look at adjusted R square. Okay, the maximum difference between adjusted and the R square is 0.5, 0.5%. If there is any too much of deviations between the R square and adjusted R square, then your model will be inaccurate. So that is the interpretation for this first model. We have to take R square. Second model. Before going into the second model, let us see the third table. This is called coefficient table. What is that? Here the model, first model, income. We have second column unstandardized coefficient, standardized coefficient, D value and P value. We have income. Okay. The second column B means beta. We have discussed y equal to a plus bx. Bx means beta coefficient of independent variable. Here the coefficient of, this is the coefficient 0.611. Coefficient of independent variable is income 0.611. Okay, this is what impact. 1% change in the income or 1 unit change in the income, the consumption will increase by 0.611. 0.61. So this is the interpretation for the beta coefficient. So what is that A? Intercept, constant. This is called constant, 15.116. Okay. Now coming to the T value, you have to look at this file. Yesterday I told you T value. The corresponding to the independent variable, the T value should be more than 2. More than 2. If it is a more than 2, it will automatically showing the significant here. So because of more than 15, the t value, because of more than 2, the t value, it is showing the probability value significant. Significant at 1% level. Understand? So I have clearly explained how to interpret the regression output. First, we have to look at the significant value. Then we have to look at the beta coefficient, whether it has a positive impact or negative impact. It is positively influencing on the consumption. When the income is increases, consumption also will increases. Okay, so that is the thing we have discussed in the correlation analysis also. Okay, now coming to the second one. Second table shows that ANOVA F statistic, Fisher statistics. The Fisher F statistic shows that how far the model is fit exactly. So the F statistics should be significant. Should be significant at 1% or 5% significance level. If it is like that, then your model is fit for prediction. Your model is fitting for the forecasting. Okay, so now these three tables I have explained. Now let me show in the PPT. Yeah. Output sheet not visible. Yeah, you can see the output view. So this is what a first one, R square I have discussed. The coefficient table I have discussed, the beta coefficient. And then this is the test statistics value, then significant. Let me show in the PPT also. Yeah. So in the regression, I hope you can able to see the PPT. In the regression, we have to consider three important value. One is R square, and second one is beta value. Beta value may be a positive or a negative, and then the third one is significant value. Okay, with this, whatever I have discussed in the SPSS, the same I have shown in the PPT also, and you can look at the interpretation. So this is the way you have to interpret. The table coefficient of determination R square is 0.96, which indicates the overall model predicts about 96%. Sorry, here not 5, here the 4. Because it is showing what is that result here 96. Fine. So 96% it's showing the overall model explained about 96. The remaining 4% is explained by some other variable. So we don't know what exactly. We should not write all those variables here. Just we have to write some other variable. So this is called unexplained variable. Coming to the next one, beta coefficient. Our output, the output we got it, the beta coefficient, positive beta coefficient. The beta coefficient shows positive, which represents 1% change in the income leads to increase the consumption by 0.61%. So this is very important. As I told you in the earlier impact, to what extent the consumption influence on the, to what extent the income is influencing on the consumption. So here 1% changes, 1% increase in the income. Why increase? It is positive. That leads to increase in the consumption by 0.61%. Sir, what is if it is negative coefficient? Which means that suppose if you're getting a negative beta coefficient, how to interpret that? 1% change in income that leads to decrease the consumption by 0.61%. Okay, so this is the way you have to interpret when you are getting both positive or So when you're getting positive I or negative. Coming to the third one, the since the value of model is lesser than the 0.05, we have to interpret, we have to conclude that there is a positive and a significant impact of income on consumption. Hence, alternative hypothesis, there I have mentioned HA, either you can mention H1 also, alternative hypothesis accepted because it is lesser than 0.05. Okay, I think I have completed the simple linear regression. Coming to the next one, multiple linear regression. What is that multiple linear regression? In simple linear regression, we have dependent on linear regression. We should have independent variable, multiple independent variable. Okay. So when I say multiple independent variable, you have to look at what kind of variables you are going to take for your study. The independent variable itself should not related more than 0.80%. It should not be highly related between the independent variable, between the explanatory variables. Now the objective, suppose, look at the objective for the multiple linear regression to examine impact or influence of consumption, investment, and expenditure on GDP. Okay, these three variable: consumption, investment, expenditure on GDP. Now, sorry, the dependent variable is GDP. Okay, independent variable is consumption, investment, and expenditure. Now we have classified what is the dependent, what is the independent. Now, how to write the hypothesis? Same. Just we have to include the variable names. That's all. What we have discussed already in the simple linear regression. There is no influence of consumption, investment, and expenditure on gross domestic product. The alternative hypothesis says there is an influence of consumption, investment, and expenditure on GDP. This will move on to the equation. So what is the equation which we have discussed earlier? Y equal to A plus B1x. Okay, now since it is a multiple regression, we have to just extend the independent variable. Okay, as per the number of independent variable we are considering for this. So here three independent variable, one dependent variable, Y GDP, A plus B1 consumption, plus B2 investment, plus B3 expenditure, plus U error or disturbance or residual. There are other names for U. There are a lot of names out there. Okay. Now, coming to the data set, all of you please open the data set. Let me share. Go to File, Open. Data. Multiple regression. Select multiple regression. One. Then okay. Yeah. This data set already we have used for multiple correlation, but same we are going to use it for multiple regression also. GDP, government expenditure, consumption, investment. Okay. Now go to analyze, regression, linear. Go to analyze, regression, linear. Here dependent variable is GDP. Independent variable is government expenditure, consumption, investment. Okay. So one dependent variable, three independent variable, statistics, as I told you in the simple linear regression. No need to select anything, let it be as it is. But only one thing is we have to select here. What is that? Since it's a multiple regression, we have to check collinearity diagnostics. Let me tell you what is multicollinearity. So the collinearity diagnostic only we are telling multicollinearity. Multicollinearity means when you are selecting more than one independent variable for your study for the regression, it should not be highly related between each and one independent variable with the another independent variable. If it is highly correlated, if it is highly showing the relationship, then am I audible? Am I audible, sir? Yeah. Fine. Yeah. So if it is highly correlated, then your total model will be wrong. Okay, so the between the independent variable should not be highly correlated. That is 0.80. It should not be more than 0.80%. For that only we are checking collinearity diagnostics. Let me tell you while doing the interpretation. Plots, nothing, no need to change. Save, no need to change. Option, nothing. Then finally we have to click on OK. Now we got the output of multiple regression. Yeah, I just want answer from you all because I already told in the regression, a simple linear regression. Now I am just expecting the answer from the participants. You just post it in the chat box. The first table, what the first table explains. Yeah, you can unmute and you can answer for the first table interpretation. So what is the R? Yes.
The regression coefficient. Coefficient of determination.
That is R square. Okay, what is that percentage R square? What is the percentage R square?
98%.
98%. Now, how will you interpret for this R square for your study? Now, this is the model. Okay, one dependent, three independent variables. Now, this model explains 98%. Can anyone interpret this 98% R square?
%98 of relationship is explained by these three independent variables.
Not
or predicted by.
Yeah, predict. Okay, okay, fine. So the overall model explained by 98%. Okay, which means that these three variables joined together predicting the gross domestic product 98%. Okay, fine. Coming to the adjusted R square, as I told you, adjusted R square means is it the three variable are significantly influencing the dependent variable exactly. When I say exactly, what is that exactly here meaning is the adjusted R square and R square, the difference, the gap is 0.5%. Here we're getting exactly. Okay, so so whatever we have done based on this, it is exactly accurate. Now coming to the third one, is coefficient. First, we have to look at significance, the probability value. Look at the significance here, SIG. We have government consumption investment. These are all the independent variable. Government expenditure, we have less than 0.001. It's 0.001, it is 1% significance level. Corresponding to this government expenditure, we are getting the t-value 5. I told you it is since it is a more than 2, that is why it is showing significant. Coming to the consumption also significant, but 5% significance level. Investment also significant, but it is showing 1% significance level. Now, look at the beta coefficient. The beta coefficient positive, negative, So all the variables are showing positive beta coefficient. 1.91, 0.36, 1.4. These are the beta coefficient is not at all expressed in percentage. Okay, so how we are going to interpret for the beta coefficient is 1% changing, was 1 unit changing. Okay, it depends upon the variable measurement. Okay, now, so we have done R square, we have done beta coefficient, we have done probability value. So what is that now? I can able to summarize based on the output. The government expenditure, consumption, and investment have positive and significant impact on the GDP, gross domestic product. Okay, this is the common statement. Common means the output. Okay, based on the output, I have interpreted. Now, coming to in-depth interpretation, GDP, government expenditure. When 1% increase in government expenditure, the gross domestic product will increase by 1.91%. Coming to the consumption, when 1% increase in GDP, GDP will increase by 0.36%. And then investment by, when 1% increase in the investment, the GDP will be increased by 1.4%. So this is a way you have to interpret for multiple regression also. Now coming to the next, another very important thing is collinearity. We have selected the option multicollinearity. We have two criteria to check the multicollinearity. Sir, you have told the relationship, whether it is highly related or not, how we can identify as a researcher. That things can be identified in the correlation analysis itself. In the correlation, while doing a correlation, you will be getting the output of correlation. In that, what is the relationship between each and every variable, whether it is highly related or adequately related. Okay, so if it is highly related means fine, no problem. But when you take that variable to the regression, you have to carefully consider those variables. Because when you include highly related independent variable for your study, your R square will be showing 98%, 95%. Which means that you're right, you're accurately predicting, but somehow they will raise a question. How you can accurately tell this variable influences this variable? Okay, but here this is the logic. GDP is influenced by government expenditure, consumption, import, export, investment. That is why it is showing the R square. What is that? 98%. The remaining two variables, I can tell I didn't include import and export, but we cannot say exactly this the other variable name in your study. Just we have to tell other variables influencing by 2%. Now, there are two criteria we have to check the collinearity. One is tolerance, another one is VIF. What is the VIF? Variance inflation factor. Variance inflation factor. So what is the criteria to check whether the independent variables are highly correlated or not correlated, not highly correlated? The VIF value should be less than 10. The VIF value should be less than 10. If it is less than 10 for all the independent variable, then we can conclude that there is no collinearity, there is no multicollinearity between the independent variable. Okay, that is the thing. Coming to the tolerance should be lesser than 1. Okay, usually many researchers will be considered the VIF not tolerance 1. Okay, so the VA variance inflation factor, the criteria is less than 10. Since it is more than 95% the R square, that is why it is showing the collinearity. So there is a problem of collinearity. According to the tolerance, this is okay, but VIF values, it is showing more than 10, then there is a problem of collinearity. Okay, so we have to consider all those things by doing the multiple regression and okay, fine. Let me show the output here. So this is the output what we have discussed in the SPSS, and these are all the articles for the reference how to write the interpretation. Let me show one article. Yeah, I have received one question from Smita. Tolerance, once more, please find. Yeah, tolerance actually for multicollinearity checking, we have to check collinearity diagnostics in the SPSS when you do the multiple regression. In that, VIF value should be less than 10. The tolerance level should be 0 to 1, the values. If it is 0 to lies 0 to 1, there is no multicollinearity in your independent variable. But here, we have to look at mainly factor, not tolerance level. So the variance inflation factor should be less than 10. If it is less than 10, then we can interpret, we can conclude that there is no multicollinearity between the independent variables. We have 3 variable in multiple regression. Out of 3 variable, only 1 variable showing lesser than 3. So lesser than 10. The remaining 2 variables showing more than 10, which means that there is a problem between the 2 variables. It is highly correlated. So in that, what is we have to drop one variable from our model. Okay, we have to drop one variable from our model. Then we have to include another variable which is relevant for your study. Okay, sometimes we can able to justify. These are all the relevant variable I have taken for my study with the evidence. Okay, that we have to. So let me show the PPT. Yeah, I have cleared. I think the Smita, I have cleared your doubt. I hope. I'll come to your questions. Wait. The chat box. Yeah. Let me show one paper for the yeah. This is the paper where they are published in ASBM Journal of Management. I don't have the published copy, where I lost that copy. So this is the behavior of institutional investors in the Indian stock market during the effect of demonetization. So where you can see here the objective, my objective is to analyze the influence of FIIs and DIs on the Indian stock market during pre and post demonetization period. Hypothesis also I have done based on the objective. This is the regression model, multiple regression equation. Actually, this is called it as in finance, we are calling it as model. Okay, equation. Have done correlation analysis and regression analysis. So here you have to take, so when you take when you are doing more independent variable, you have to interpret differently. Okay, so here since I have done pre and post demonetization, first table shows the pre demonetization when the Sensex Nifty mid cap as a dependent variable. The independent variable, this independent variable for each, this is one model and this is another model, this is a third model. So you have to put dependent, independent, beta coefficient probability value. This one no need. That been Watson test, no need. This will be applicable only if you are doing finance related research. F statistics, the goodness of how far your model is fit for the prediction, and then this is R squared. So based on that, you have to interpret what I said earlier. So this is available in the Google Scholar itself. Let me share the link also. Fine. I think so. Meanwhile, let me answer for your questions. So whatever you have posted in the chat box. Link, let me share, Dr. Tina. And so what is the difference between R square and adjusted R square? As I said, there is nothing R square and adjusted R square. Both the R square, both adjusted and as well as the normal R square shows the coefficient of determination. How far the model explains. Okay, how far the model predicting the independent variable on dependent variable. Okay, adjusted R square means how really these independent variable influencing on the dependent variable. So that is why. So the difference is 0.5, which the actual difference will be 0.5. If you are getting more variations between the adjusted R square and the normal R square, then your model will be wrong. And always, please keep it in your mind, the adjusted R square will not show the adjusted R square should not be in the minus value. If it is a minus value, the entire model will reject the limit. That is the difference. That is a question of Ritu Sharma. Yeah, Deepa, she has mentioned what is the acceptable p-value for T in coefficient table. What is the acceptance? Ma'am, actually here the T statistics, that is the test statistics. The test statistics value actually manually how the values will come. Coefficient divided by standard error. What is the coefficient? Beta coefficient, what we have seen in the regression. Beta coefficient divided by corresponding to the standard error, you will be getting the value of T statistics, test statistics, T statistics. If the T statistics is greater than 2, the value is greater than 2, automatically your probability value will be significant. That is true. Okay. Suppose if the T value is lesser than 2, then it will not probability, it will not statistically significant in the table. That is that is we can say that is secret also. So nobody knows how the T test statistics will be calculated. Okay, so test statistics will be calculated coefficient divided by standard error. And then also how to calculate marginal effect of mean to analysis of multiple linear regression. Sorry, I couldn't understand your question. Marginal effect of mean. Sorry. If we explain clearly, I can discuss about this marginal effect of mean. Yeah, you can accept. Yeah, again, one question from Deepa. Ma'am, we can accept either 1% level or 5% significant level. Sometimes, in finance related research and all, they will accept till 10%. Okay, which means that 90% they are estimating their results will be accurate. Only 10% will be getting a chance to getting a chance of getting the error. Okay, since it is a time series data, since it is a published data, they will usually they will keep till 10% as a significance level. And what is that? Kannan, if IV also more than 1, in that case, how to analyze? Yeah, that is multiple regression. You're asking IV or D? IV means if it is more than 1 or 2 IV means we can do multiple regression. I think your question is dependent variable. Dependent variable is 1 or more. You can go structural equation model. Yeah, where do we use standardized beta? Exactly, good questions, into Matthew. We have unstandardized and standardized data. Unstandardized data, why we are taking unstandardized data? Because the variable, we have to consider the variable. So how many variable you are taking for the study? All the variables should be in the same measure. Suppose, for instance, you are considering the age, height, weight as an independent variable. Height is measured in terms of inches. Weight can be measured in terms of kilograms. Okay, income can be measured in terms of rupees. So all these three variables are measuring in terms of different units. Okay, if you are using this kind of different units, we have to go for unstandardized coefficient. What is the standardized? When you are taking the same kind of measurement variable, that time only you have to consider standardized. So my advice is don't go for the standardized, because so many procedures we have to calculate for the standardized coefficients. Better take unstandardized coefficient. I hope I have cleared your doubt into Matthew. Yeah, of more than one dependent variable means you can go for structure equation model. And if suppose if the dependent variable is categorical variable, suppose sir, my dependent variable is categorical variable, independent variable is metric variable. In that case, you can go for logistic regression. That's a very interesting topic, logistic regression. We have there also bivariate binomial logistic, multinomial logistics we have. You can slowly learn all those things. Yeah, how to correct the multicollinearity problem without dropping. Yeah, so when you do the correlation analysis, you have to check all the variables are related, correlated lesser than 80%. It should not be more than 80%. If it is more than 80%, there itself you have to drop the variable. Okay, you should not consider those variables. Suppose if you want to consider those variables, then your R square will be increased. Then you have to justify during your representations or whatever it is. Yeah, we'll share you the PPT as well as the link of the papers. Yeah, what is the difference between Dr. T. Ramya, the questions? What is the difference between semi-model and multiple regression interpretation? Madam, multiple regression is the base, simple, and multiple regression is the base for the prediction. Okay, for forecasting or estimating the variables. Structure equation modeling, it is the advanced model of regression. That is the difference between both the things, structure equation modeling and multiple regression. If you know the multiple regression, you can go for structure equation modeling. Okay, in the structure equation modeling, you can use n number of dependent variable and n number of independent variable. Okay. So that is comes under multivariate techniques, multivariate statistical techniques. I hope I have completed. Babu sir. I'm getting the
Dr.
questions.
Satish, there's one more question from our YouTube channel. Could you please
Yes,
respond to that?
yes, ma'am. Yes. Yes, ma'am. Go ahead, ma'am.
So I've posted it on your personal window. Can you see your
Yeah,
chat
fine.
messages?
Unstandardized coefficients we want as well as seen in the output file. So yes, one means what? 2.5, 3.5, which means what is that? 1% changing the government expenditure, the GDP will be increased by 2%, 3%, whatever it is. Okay, so like that we have to interpret. And then, sir, can you explain? Yeah, I have answered for this question. Multicollinearity problems without dropping the variable. So if you don't want to drop the variables, you have to look at the correlation analysis itself. Okay, so no need to again check the multicollinearity in the regression. Just for cross verification, you can check. Okay, so if you want to drop the variable, you can exclude the variable and include one more variable also instead of that. So that is my suggestion.
Dr. Satish, just a quick request.
Yes,
The questions are directed to you personally. So, if you can just tell us what the question that you're addressing is, also will be useful, sir.
Which question, ma'am? Sorry.
The previous two questions you answered were
Yes,
typed
yes,
on your
yes.
direct chat window. So, if you can just tell us the question also before you answer, it will be useful,
Okay.
sir.
Okay, okay, okay.
Thank
So should
you.
I repeat the answer for that, ma'am, now?
Just the one on the unstandardized coefficients.
Yeah, can unstandardized coefficient be more than one as per the result is seen in the output size? So the answer for this is, now should I tell or write it in the chat box?
So you can respond, sir.
Okay, fine.
This is from our YouTube channel, so they will be able to hear you only if you respond.
Fine, fine. So can unstandardized coefficient, you can use, you see, the answer, whatever it is, more than one or two or three, whatever results you are getting, the big coefficient, the only thing is you have to interpret. 1% change the government expenditure. So for instance, government expenditure, I'm getting 2 beta coefficient, 2.30. So how to interpret 1% change in the government expenditure, the gross domestic product will be increased by 2.3 percentage. Okay, so you can use percentage or you can use unit. Okay, whatever, it depends upon the researchers' interpretations. That is the thing. So that is the answer for the unstandardized coefficient if it is more than one. And coming to the next one, sir, can you please explain how to correct the multicollinearity problem without dropping the variable? Obviously, we cannot do anything if the multicollinearity when the multicollinearity problem will be arise when your independent variable relationship showing the relationship is more than 0.80%. If it is like that, then obviously the problem will be arise multicollinearity. So we have to drop the variable and include one more variables which is relevant for your study. Okay, so all those things to avoid this multicollinearity problem, before itself the correlation, when you do the correlation analysis, you have to rectify the problem there itself and then come back to the regression analysis. That is the purpose we are doing correlation analysis. Yes. Yeah, I have cleared any other questions? Any other questions in the YouTube?
So as of now, there are no questions, sir. Participants on both the channels could ask your questions if any. We have about 10 more minutes before we can close the session.
Yeah, Rentil, Matthew, how to rectify if the multicollinearity exists means obviously we have to drop the variable only. We have to drop, which is irrelevant for your study, which is not statistically, which is not statistically significant.
Sir, any other further remarks you have to make, you could, sir. We are currently not having any questions pending to be answered. Participants are requested to fill in the feedback form that is displayed on the screen. We have also shared the link on the chat box. Our resource person was here answering your questions so long. He's had a problem with his audio again. Since we were at the end of the session, we will take that into consideration. Please fill in the feedback form, dear participants.
I think I have cleared everything as per the agenda of today. So today we have discussed regression and correlation. In the regression, we have seen dependent as well as the independent variable. And with the continuing of today's session, we have a tomorrow's session that is regression analysis. Actually, we have discussed dependent and independent variable. There is one more variable is called mediation variable. So how to use that mediation regression analysis, that will be covering by Dr. Azrar Ahmed from SIME. So all of you attend that tomorrow's session without a fail, so that you can understand how to incorporate the median variable in the regression analysis. Any other questions? Babu sir, are you there?
Sir, just a minute. We are trying to connect, sir.
Okay.
Sir, now you are a co-host. You can unmute yourself, sir. Yeah, you can unmute yourself. Yeah.
Yeah, and
you can on your video. You become a co-host.
yeah, just a minute, sir. Sir, I have completed because internet connection got disconnected. So I have connected through my mobile. I have completed the session. I have answered for the questions also. If you have any, if they have any other questions, let them ask. I am ready to answer for that. Hello.
Sir, there is one question which is when do we have to use log or in data set? I don't know what
Ma'am,
that means.
log will be using for the time series data set. Logarithm functions will be using only for the time series data set, not for cross-sectional data. So when you have a different kind of measurement variable, you have to bring all the variables in the uniform level. So that time you have to use logarithm function in the Excel sheet itself. So logarithm functions will be using only for bringing all the variables in the uniform format. That is the purpose.
Recording in progress.
Yes. Ma'am, I think I'm cleared about the questions. Hello.
Yes, sir.
Yes, any other questions?
Sir, how do we deal with common method biases?
Sorry, ma'am.
How do we deal with common method biases?
Common method biases. No, in which area they're asking, ma'am? That biases and all. I'm not clear with the questions.
Sir, that's it, sir. We don't have any further questions. Mr. Intil Matthew, you can unmute yourself. If you have a question, you can ask.
Yeah, I am the one who asked the same question, common method biases, like, homogeneity, endogeneity, multicollinearity, on those things.
Yeah. If it is, see, your variation also, see, we are looking mean and the standard deviation. Okay, so the standard deviation also will not be very much higher. Okay, if it is very much higher, then there will be a problem of heterogeneity. Okay, so your data should be homogeneity variations, not heterogeneity. Okay, so that and all no need to consider here. When you go for the finance related research, that time you have to look at whether the data is homogeneous or heterogeneous. For that, one more test is there. Okay, I'm not. I don't have a idea about the name of the test. Brush backend test. I think I'm sure. I'm sure brush backend test. We have to test whether it is the data is heteroscedasticity or homoscedasticity.
Okay, sir. Thank you.
Okay. Yes. Yes, ma'am. Any other questions, ma'am?
Dr. Babu, if you're okay, then we can wrap up, sir. There are not any no more
Yeah,
questions
I
in the
think
chat, sir.
there is no further questions, even in YouTube, I think so. So I think
No,
we
sir.
can
No further questions on
just,
YouTube either.
um, you know, propose the vote of thanks now. Yeah.
May I request Miss Pallavi to take over? Miss Pallavi?
Yes, ma'am. Okay. Yes, ma'am. Am I audible?
Sound, you're not audible, Pallavi.
Okay. Am I audible now?
Yeah.
All right. Greetings to everyone who's been part of faculty development program organized by Internal Quality Assurance Cell of St. Paul's College. On behalf of St. Paul's College and the participants, I express my gratitude to the resource person of today's program, Dr. Satish P. It was an indeed informative and highly enriching session, sir. Thank you for explaining such complex topics in a simple way, which I'm sure it helped a lot of us. I would also like to thank key members of the faculty development program, Reverend Father Thomas MJ, Principal St. Paul's College, Father Dr. Sajid Suryak, Vice Principal, and the Administrator of St. Paul's College, Father Aroke Sami. I also thank Dr. V. Babu, IQSC Coordinator, and Mrs. Saranya Francis, IQSC Secretary, and Mrs. Kavita, and the team members of IQSC from both St. Paul's College and Mount Carmel College. Last but not the least, I thank all the participants for your participation on both the platforms, that's on Zoom and on YouTube live streaming, for participating here. Thank you again and have a great evening.
Yeah.
Thank you, Miss
you.
Before
Pallavi.
that, let me thank.
Thank you very much. Thank you very much,
Yes, ma'am,
sir. Thank you.
Yeah, thank you, ma'am, for the vote of thanks. And once again, I thanks to Babu sir and the St. Paul's College and Mount Carmel College for giving this opportunity. And also, I should thank to Dr. Selvi from Jain University That's all. Thank you.
Thank you very much, sir. Satish, sir. Yeah.
Thank you, sir.
Thank you, Dr. Satish. Thank you,
Thank you.
Pallavi, for your very lively presentation of the day. I now hand it to Dr. Babu and the technical team to wind up today's session. Participants who have filled in the feedback can leave the meeting.
Yeah, sure, madam. Other than 10 minutes, we will wind up.